Hello! Today we're going to do a video about how to convert from denary or decimal to binary. These are two systems to represent numbers. We're most used to the denary because it's the one we have 10 fingers in our hands, is the one that we're used to. But binary is used by computers, so we need to know how to convert from one system to the other. The first thing we're going to remember when we convert from from the decimal system to any other system is we're going to write the base of the other system from right to left and their exponents of the position. So I'll show you. The first thing we're going to do is if we want to convert to binary, is we're going to write the positions in this way. 2 to the 0, 2 to the 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 5, 6, and 7. And we could go on, but we're going to stop at 7. Okay, so the next thing we're going to do is either above or below. I like to write the below. We're going to write the values of this. This is the base to the exponent, and the exponent is the position. So we're going to write the values of that in decimal. So that's 2 to the power of 0 is 1, 2 to the power of 1 is 2, 4, 8, 16, 32, 64, and 128. Okay, so we get the values by getting the base to the power of the position from right to left, and this is done in any system from which we want to which we want to convert if we start with a decimal system. Okay, so having seen this, let's go and check some examples. Imagine we want to convert the number 84 in denary. Okay, so what are we going to do? We're going to write those numbers as we said: 128, 64, 32, 16, 8, 4, 2, and 1. And now what we're going to do is we're going to see which number can fit into 84 without it being greater than. So 64 would be the first number that is the highest number that can fit into 64 without being greater than it. So we put a 1 there, and then we do 84, 84 minus 64, and we want to see how much we have remaining, the remainder. So that's 20. So which number in the powers here of the base can we is the highest we can put without being higher? So 32 is higher, that's a 0. 16, okay, so we put a 1 there, and we do 20 minus 16 to see the remainder, and we get a 4. And now it's easy because 4 is a power of 2, so 8 is too much, and we put a 1 here in the 4, and so 4 minus 4 is 0. We haven't got any remainders, so we can put the rest to 0. What does that mean? It means that 84 in denary can be written in binary as 1, 0, 1, 1, 0, 1, 0, 1, 0, 0. Okay, so that would be the first example. Let's go and do another one. 132, for example, in decimal. Well, again, we get the bases and we write them in the powers of the positions: 128, 64, 32, 16, 8, 4, 2, 1. And then again, we're going to see what number can we write that doesn't go above 132. 128, if we do the next power, it's going to be higher than 32, so that would be a 1 here. Let's look at how much we've got remaining. 132 minus 128, that's 4. And that's great because that's a power of 2. So then we have 0, 0 here, 0 here, 0 here, 0 here. Hey, that's the 4. So we write a 1. 4 minus 4 is 0. We don't have any other remainders, so we can just write the rest of the positions until we fill the number to the right as zeros. Okay, so 132 can be written in binary as 1, 0, 0, 0, 0, 1, 0, 0. Okay, so that would be how to convert from one to the other. This is the method I use. This is the method most people use. It's not the only one, there's various. Today we're going to see two. We're going to see two methods. Why? Because I want you to be able to, in exams, if you don't remember one, be able to use the other one, but also because either one of these methods is good when we're converting into, or is more efficient when we're converting into another system, decimal, octal, etc. So it's good to understand and know both of them. Okay, so let's look at the second system, the second method. And we're going to use the same numbers, okay, so we can check them. So we had 84, and we're going to use the second method. What is the second method? Okay, so we're going to divide the number in decimal by the base of the new system, in this case 2. 84 divided by 2 is 42, okay? So if we don't have a remainder like here, so if it's an exact number, we're going to write a 0. And then we get that number, 42, and we divide it by 2, sorry. And that's 21. And then again, it's an exact division, so a 0. Now 21 is an odd number. So that's when you divide it by 2, it's going to result in a non-exact number. It's going to result in a fraction. So that's 10.5. And as we have 0.5, that remainder, so we're going to write a 1 when we have a remainder, when it's not an exact number. So, and then we get only the whole number there, not the 0.5, just the 10, and we divide it by 2 again. That's a 5, and as we don't have, it's an exact division, we have a 5. We write 0. Now 5 again is an odd number. When you divide it by 2, it's going to be 2.5. We're going to have a decimal part, so that's going to be a 1. And we get the whole part, the 2, and we divide it by 2 again. And that's going to be 1, and that's a 0 there. And 1 divided by 2 is 0.5. So that has a fraction, and that's going to be a 1. And now we're going to write the number from the bottom to the top. Okay, so 84 in base 10 is 1,101. So from the bottom to the top, 0100. See, 101, 0100, 101, 0100. Okay, so let's check. Was that correct? 101, 0100. That's correct. Okay, so we get the same result. Now let's do 132 in the second method. So again, 132, we're going to divide it by 2, and that's going to be 66. And it's an exact division, so it's a 0. 66 divided by 2 is going to be 33, and a 0 because there's no extra. And then 33 is an odd number, so that's going to be 16.5, and that's a 0. And then we get just the whole part, so 16, not the fraction. We divide it by 2, and that's going to be an 8, and it's an exact division. So we write a 1 there. And then we get just the part before the decimal point, and that's going to be 16 divided by 2. It's 8, and as it's an exact division, it's 0. 8 divided by 2 is 4. 0. 4 divided by 2 is 2. That's a 0. 2 divided by 2 is 1, and it's again another 0. And 1 divided by 2 is 0.5, and it's a 1. Okay, so that was a 0 and a 1. And if we start from the bottom to the top, we get that 132 can be written as 1, 0, 0, 0, 0, 1, 0, 0. So that's 1, 4 zeros, 1, 0, 0. And let's check that. 1, 1, 2, 3, 4 zeros, 1, 0, 0. Exactly. Okay, so 2 methods to check. There are some more, but these ones are the easiest ones, and I hope you understand them. And you'll see that when we convert to other systems, we'll be using the same method with different bases.